Hey, Troy Howard Middle School. Welcome to another Tech Ed Enrichment. Today, what I've got going for you is a little bit about engines, small engines specifically. And I'm going to teach you about how a four-stroke cycle engine works and maybe a little bit about a two-stroke cycle. Just some basic stuff, knowledge about engines that I think everybody should have. There are three different types of engines. There's an internal combustion engine. We know combustion means burning, so in an internal combustion engine, there's a burning or exploding of fuel happening inside the engine. There's something called a continuous combustion engine, where the fuel is being burned continuously, kind of like a fire in a wood stove or a fire in a furnace or something like that. And that energy causes the parts of that to move. It'd be something like a jet engine, where it's continuously burning, creating thrust and exhaust. And then there's something called an external combustion engine, which the combustion happens outside the engine, where you're burning a fuel. And in most cases, you're burning a fuel in order to create steam, like a steam engine, and then that steam is used to move the engine parts. But we're just going to focus on an internal combustion engine. And an internal combustion engine all comes down to the piston. Okay, I'll show you that right here. I'm going to be out of the picture again mostly, so you can see what I'm talking about. And here we have a couple different engines. I'll show you this one first. But inside here, we have a cylinder. The cylinder is where the piston moves up and down inside. You can see that piston is a cylindrical shaped part that moves up and down inside there. And what basically happens in every engine is that this is going to be covered. There's a part that's going to go over that called the head. And if we fill that area, that space in there, with a fuel like gasoline, and then we compress that as we move the piston up into a really small space covered by that, and then we ignite that, we make it explode, and that force of that explosion is going to be enough to force that piston down. So that's how you get movement out of that piston or out of that engine. You're basically exploding fuel, and it's forcing that piston to move. Now that up and down motion, that linear motion of that piston, not very useful, right? We want something that can turn. So that up and down motion is converted into rotary motion through something called a crankshaft. And you can see a crankshaft is connected to the piston here. And it's not a good, easy way to see that, but there's something called the connecting rod, and that rod connects the piston to the crankshaft there. That's offset from the shaft. So when it pushes it down, it's pushing on this kind of the side of the shaft. Best way to describe that is kind of like a bicycle pedal, like your legs are going up and down, and that paddle is actually called the crank paddle. It's taking your up and down motion of your legs, and it's turning into round circular rotary motion. And that's what the crankshaft is. So those are the main components of every engine. You have a piston and a crankshaft, and one is designed to create that power, and the other is designed to convert that linear motion into circular or rotary motion, I should say. That can be used to power something like wheels, a blade, or whatever you're using it for. Okay? So that's the basics behind every engine. You have combustion, pistons, and a crankshaft. And we're going to focus first on what's called a four-stroke cycle engine. There's a lot more that goes on than that, but we're going to start with some of the basics here. So when that explosion happens, we said that piston moves down. There's a little bit more that's going on there. For one, we need that fuel to come into that area of the cylinder. Let me get this thing started. Okay, so first thing we have to have happen, there we go. Let's say we start this engine, and the piston, we start moving down. And if you can see that, but as that piston moves down, well, let me back up a little bit, actually. The four strokes means that there are four movements of the piston. Each movement of the piston, something different happens, and then that cycle starts all over again. So we're going to go through those four movements. And the first movement, where the piston is moving down, is called the intake stroke. And the intake stroke, as you can see, when that piston starts to move down, that space is expanded. In other words, there's a volume is increased, and something has to fill that space. There's a vacuum created there. There's suction created there, and that suction is enough to suck fuel into that area. And if you notice carefully, if you look closely, you'll see when I move this piston down, at the same time, this thing kind of popped up, and that's called the intake valve. So I'll do that again so you can see it. So when this thing piston moves down, that suction is created. Now this valve opens up, and you can see it opened up a little bit there, opens up, and that valve allows the fuel to go into that combustion chamber. So when the piston goes down, it's sucking that fuel in, and that's called the intake stroke. So that's stroke number 1. Once the piston gets to the bottom, you'll notice the valve is closed now. Actually, there's 2 valves. This intake valve is closed. And now the piston's going to come back up. In this case, both valves are going to stay closed. That fuel that we pulled in there during the intake stroke is now being compressed into a really, really small space. And when you do that with something explosive or volatile like gasoline, it has a tendency to want to explode. So when we compress that fuel mixture in that combustion chamber, it's going to get really, really explosive. And just before it reaches the top, we ignite that fuel. It's not going to quite explode on its own. We need something to spark it. And that's where a spark plug comes in. Here's a spark plug right here. You guys have probably seen a spark plug. And a spark plug causes electricity to jump across these two electrodes here. And you have a little bit of a spark that happens just at the right time, and that spark is enough to ignite the fuel. And once that fuel is ignited, we get our explosion. And that explosion is enough to force that piston down. So that's called our power stroke. So we went from the intake stroke, where the fuel is sucked in, and then the piston came up, and that's our compression stroke, where we compress the fuel. And now this is our power strokes. That's where we're getting the real work happening. We're getting a lot of force pushing that piston down from that explosion. And as soon as it gets to the bottom here, what we have left after we burn fuel is exhaust, right? Smoke. So we need to get rid of that. So as the piston swings back up, you'll notice that this valve, which is called the exhaust valve, opens up. And that valve simply just opens up to allow the piston, as it's coming up, it's pushing out that exhaust, pushing it out through the exhaust system, which would be a muffler or something like that, right? And then the cycle starts over again. So we go to our intake stroke, the valve opened up there, and then the compression stroke where the fuel is compressed, and then the spark plug fires and that fuel explodes, and then you have your power stroke where the piston gets powered down, and then finally the exhaust stroke where the exhaust gases get pushed back out through the engine. And that's a simple 4-stroke engine. That's how they operate. That cycle just goes over and over and over again. And some engines you could have more cylinders and a little bit more complexity than that, but that's the basics right there. Now, so there are more systems there to an engine. So let's take a look at some of the different parts of an engine, some of the different systems there. We'll start with since the intake stroke was the first part of that cycle, let's start with what's going to happen now. Let's look at this engine again. And we saw that we have valves on the top, and something had to move those valves, right? So that's the function of this little part here, which is called a camshaft. And look closely at a camshaft, you'll see it's got a gear that's going to be driven off of this gear here, so that's going to go inside there. And then around this part of the shaft, you see high spots, or these are called lobes or cams, and they're sticking up in different locations. And those lobes will have something called a valve lifter riding on top of them. And those valve lifters, those are the things that actually push those valves up. So when this camshaft is turning, when that lobe gets around to that lifter, it's going to push that lifter and valve open. So you can see how they're set off in different locations because the valves open at different times. You can't have them in the same spot. So a camshaft, first of all, you have to put your lifters in the engine. So we slide those down in there into those two holes, and then we can put our camshaft in. Now the camshaft has to be timed correctly. When you put this in here, we can't just have those valves opening anytime, right? We want them opening at the right time. So there's a little mark on this gear and a little mark on this gear. And when you go to assemble that, we make sure that those two marks coincide with each other. Otherwise, like I said, those valves will not open at the correct time. So we slide that in there, and now we've got our camshaft assembled. So now, when we turn this engine, you should be able to see those valves opening. There goes the exhaust valve, pushing the fuel out through the exhaust Oops, sorry, that was the intake valve. That's the intake valve. Turning that the wrong way. Let's start that again. Turn it this way. All right, so there's our intake valve sucking in the fuel. Then our compression stroke, our power stroke, and then finally this opens up to allow our exhaust out through the exhaust stroke. Okay, so there's that other system on the engine, which is the camshaft. You probably have heard of camshaft, and their function is to operate the valves like that. So that's another part of our intake stroke. Another part is the fuel mixture and how that works. Let's look at this engine here. This one's a little bit more complete. We need to have, first of all, fuel. So you can see this one's got a fuel tank attached to it. And we need to have a way to mix fuel. Fuel by itself, as we learned probably in school somewhere, that it doesn't burn without oxygen. So we need to have oxygen combined with our gasoline. And the part that helps with that, or that does that, is called the carburetor. You probably have heard of a carburetor. Engines have this, small engines especially, have a carburetor like this. And the carburetor's function is to take that fuel, mix it with some air. Air comes in through the top here. This one has a filter that filters the air, comes in through the top. And then that mixture is then allowed to enter the engine. Okay, and that's our fuel mixture. So the carburetor's function is to control that. Regulate how much fuel and air go together. The mixture's got to be right. It also changes how much of that goes in. How do you speed up an engine? Well, you put more fuel in. You allow more fuel to get sucked in there, get a bigger explosion, more power, faster engine. So the carburetor is really what regulates the speed of an engine. You can see my throttle thing I'm moving right here. I hope you can see that. That's the throttle right there. So when I throttle it, I'm allowing more fuel into the engine or less fuel to slow it down. So the carburetor is part of that system. So we have the camshaft. Let's see what else we have here. Oh, yeah, I should mention too, the air that goes into an engine has got to be relatively clean. So this is part of a filter system that cleans that air. You know, when you're like mowing and things like that, there's a lot of dust and debris. We don't want that sucked into the engine. So usually an air filter is located closer to or on the carburetor. All right, so our next stroke was our compression stroke, which was simply that fuel was getting compressed in the cylinder. And we said when we get to the very top of that, we had a spark that fired. You can see on this engine, our spark plug actually mounted on the top here. You can see there's a wire leading to the spark plug. And a spark plug, like we said, takes electricity and causes it to jump across an air gap and make a spark. You guys have seen sparks before, and that spark is going to ignite that fuel. Where does that electricity come from? Well, it comes from something called a magneto. Let me take this little part off here for a minute so you guys can see. This is just our starter recoil, which we'll talk about in a minute. We'll take that off. And underneath there, we've got this big metal part that spins with the engine. That's called the flywheel. And it does a few different things. It does like 3 different things here. But on the side of the flywheel, there's a spot where there is a magnet right there. See how that sticks that? There's a magnet. And if you guys watched my electricity unit on electric motors, we learned that when you spin a magnet past a coil, you generate electricity, right? It's the reverse of the way electric motor works. Electric motor works, you spin a coil past a magnet, and it converts that magnetism, gets converted into electricity, or that you put electricity in, you generate motion out of it. This is similar to that, but when you run a magnet past a coil, that magnet goes past the coil right here, just at the right time that we need it to, and as soon as it does, it charges up this coil and sends electricity up through the spark plug wire to give us our spark. So that's why there's only one magnet there, because we only have one spot where we need that spark plug to fire. So that's going to spin past there. And if we spin past that, you can actually feel that. You get a little shock if I spin that, but even just at that speed, off of that spark plug wire. So the flywheel is turning. It's attached to the end of this shaft here, the crankshaft, and it's turning with the engine, and it's helping us generate that spark. And the spark plug, looks like this. Now, spark plugs, they do get worn out. They get a little dirty and worn out. They do need to be replaced or cleaned periodically. There's a ceramic part here, and remember from our first electricity video, we learned that ceramic material is a good insulator. It insulates, doesn't allow electricity to flow through it. Because we want electricity to go through one part of this, but not the other. So we're forcing the electricity to flow through different parts, and that insulates it between the two, causing our spark to happen. This little thing here, if we ground that spark, the spark plug doesn't fire, the engine doesn't run. So we can stop an engine or disable an engine simply by either shorting out that so that the electricity does not go through the spark, or simply taking that off, or taking the spark plug out or something like that. It's usually safest just to disconnect the wire. So no electricity, no engine running. Okay? So that's part of our our intake stroke, the carburetor, and we have the compression stroke, and then we have the power stroke, and that fuel is ignited by that spark plug, and it causes that explosion. And then finally, we said we had the exhaust stroke. So during the exhaust stroke, that piston is pushing that fuel out through this part here. This is called a muffler. And muffler, without a muffler, one, it would be really loud, but also you might get some flame shooting out of there. So this kind of muffles the sound, and also kind of prevents too much heat or any kind of uncombusted gases from igniting out there and creating fire. So mufflers are kind of important on an engine like that. So let's see what else we have. Let's get back to some of these other parts that we kind of skipped over here. So we've got this thing here, we said was the flywheel. Now the flywheel, besides it generating our spark, you'll notice that it's got some fins on it, okay? This is part of our cooling system. Engines like this, there's fire going on in there. There's explosions. They get hot. They get really hot. And they need to be cooled. If you didn't cool them down, the parts would expand and seize up, and you'd have all kinds of problems. In this type of engine, when you see cooling fins like this, they're called air-cooled engines. And the way they work is the heat goes up through these fins, and then you force air between those fins. And that air goes through there and takes the heat away. It cools them off. And so you've got fins up here on the head. You've got right on the engine block, you've got some fins there. And what creates that air movement are the blades on this flywheel. So it acts like a fan. And that fan is inside here, so it can direct that air up through here to the parts of the engine that need to be cool, like that. So that flywheel is part of the cooling system as well. Another thing the flywheel does, it's really heavy. It's made out of cast iron. Remember our metals unit, we learned about cast iron, our metals video. It has some weight to it. It's designed to kind of smooth out that flow. Without a flywheel or something heavy like that rotating on there, the movement of our shaft would be much like the movement of our piston. It would be really kind of uneven, and it would move up and down, slow at times and fast at others. And this, what that does is it helps carry that piston through some of those other movements that are not powered, and also smooths it out so we have a nice even rotation. So that's just the mass of that cast iron does all that. And once that starts moving, the inertia from that movement carries that piston. Remember, there's only one stroke that's actually powered down. So in order to move that piston through the other strokes, we need the inertia from that heavy cast iron wheel to do that. And like I said, it also kind of evens out the motion. So hopefully you understand that. So with other types of engines where you have more than one cylinder, like a car, you really don't need necessarily a flywheel like that massive one anyway. They do have flywheels, but they're not massive because you have other pistons. And the pistons are all, like in a four-cylinder car, you have four cylinders, and they're not all firing at the same time. They're firing at different times. So while one is going through a power stroke, the other one might be going through an intake or exhaust stroke. So the whole crankshaft is powered at one point by one power stroke of a different piston. So we don't need something to carry them through the strokes. Hopefully that makes sense. All right. So we got our flywheel. So the other thing about an engine is there's a lot of wear. You've got a lot of moving parts that are metal rubbing against metal. You get friction, you get wear. You need to lubricate that. So you need a lubrication system. And we all know you have to put oil in an engine in order for that to happen. And so motor oil or engine oil goes into the engine here. This engine is probably, I think it is, yes, it's a vertical shaft engine, which means the shaft is like a lawnmower. It's going to be mounted sideways. So there'd be a part here that would close that case up, the crankcase, and then the oil would pool into the bottom of that. And that in that oil pool, you would have in this case, a real simple system that this goes on here. Let's see, it goes on here like that. And this little part, I hope you can see that, has a gear that is geared off of our camshaft. And it's got little paddles on it. And those little paddles, they spin really fast. And they're spinning and dipping into that oil and flinging that oil everywhere, creating a whole bunch of oil to be spread all over this moving parts of the system. So the oil gets in between the moving shaft, it gets in between the gears, and it lubricates everything. It actually creates some pressure there that pushes up underneath the cylinder as well. So the oil, this one's a real simple one. It's just going to fling that oil everywhere. In other engines, like in a car, you'd have a pump sitting in the oil, and that oil would be pumped up through the moving parts and then cycle back down. So you really want a film of oil between every moving part, and that's going to lubricate it. It's going to keep it cool, keep it from wearing too. But that oil over time, we know that since engine's getting hot, the oil breaks down. It gets full of carbon. It burns a little bit, and it gets carbon in it, and it loses its ability to lubricate really well. So what do we do with oil? We have to change it every once in a while. It's a really important step in maintaining an engine, right? Changing the oil. So we've got our cooling system, in this case fins. It's an air-cooled system. We've got a lubrication system in this engine here. You can see where we put the oil in. Here, there's a little plug there. We just fill that up with oil. Is there oil? No oil in this one. And then there's a little oil dipper or spinner or something really simple that flings the oil around. We've got we talked about our flywheel. How do you start an engine? Well, to start an engine like this, you simply need to just start that flywheel and that piston moving. So there's just a starter rope like this, and it's connected to the flywheel. So when we pull it, it's going to start the spark going. It's going to pull that piston down, which is going to suck fuel in there, and it's going to then start on its own, right? You just need to get it going. This, in a car, you'd have an electric motor that actually gears off of a flywheel. And so when you turn the key, there's a little electric motor separate from the engine. It's not separate, but it's attached. But its only function is to start the engine moving, and then the systems take over on its own and starts running on its own. So the different ways to start an engine, either recoil or electric start, where you just turn a key. So, all right, so that's a 4-stroke engine. Those are the major parts right there. I don't remember if there's anything else I want to tell you guys. Oh, so just one more thing. Engines that don't have air-cooled systems like this, they have liquid-cooled, like cars and automobiles and things like that. A lot of them now are liquid-cooled. So instead of having fins, you've actually got little passages, little places where the water can cycle through, or fluid actually can cycle through. And there's a pump that pumps that fluid through, and that fluid gets hot, picks up heat from the engine, and it goes out. And it goes out into a radiator, which we're going to do another video on cars and how that all works. But so not every engine is air cooled. Some of them are liquid cooled. A lot of them are liquid cooled too. But, all right, so that's a 4-stroke cycle engine. Now, the thing about 4-stroke is they're pretty heavy, right? Got a lot of moving parts here. You've got oil that's got to be maintained in the bottom. They're really not good for every kind of application. So that's why we have something called a 2-stroke engine. Here's a model of a 2-stroke engine. And 2-strokes can be a little bit difficult to understand. So I'm going to try to explain this so you can understand it. There are very few moving parts on these, and it gives you a bunch of advantages. But 2-stroke means there are only 2 cycles of the piston, okay, and it starts over again. Every time the piston moves down, it's going to be a power stroke. In other words, it's going to be powered down. And then every time the piston moves up, something different happens, and then it's going to be powered down again, okay? But you'll notice there's no camshaft for valves. There's no valves on it in the sense that we have valves on this engine. So it's a little bit different engine. So it's a little complex. So the way it works, let's see if I can explain it to you. So the piston, when the piston moves up, let's say we've already got fuel in our chamber above the piston. So when that piston is moving up, what's happening is besides it compressing, it's doing multiple things at the same time. It's compressing that fuel, getting it ready to explode. And while it's doing that, since the piston is moving up inside this area of the engine where the crankshaft is, there's suction created. And that suction is enough to suck the fuel mixture into this little reed valve. There's a valve right here. Instead of regular valves, we have a little two metal flaps that get sucked open. And that suction, sucking that fuel in, fills the area below the piston with fuel. And so when the piston gets to the top, now we've got a bunch of fuel in there. And the piston, once it gets to the top, it fires. And then the piston comes back down. Now while the piston's coming down, a couple things are happening here. As the piston comes down, that fuel is getting pushed. Since there's now pressure in this area below the piston, that fuel now is getting pushed out through a little passageway. Actually, there's two here, I believe. Up, back, over the top and into the combustion chamber. So it's getting pushed into the cylinder there. At the same time that's happening, the fuel getting forced in there, you can see on this side, there's a little, when that piston goes right to there, that pressure, that fuel being forced in there is enough to push out the exhaust. So you got a lot going on there. I know it's hard to understand, but so the piston goes, then it gets to the bottom, swings back up again, and as it's going up, besides it compressing the fuel, compressing that fuel is sucking more fuel in. So it's two things happening. You're having compression and an intake stroke at the same time. And then during the power stroke, you have also, besides the power stroke, you have the intake is happening at the same time as well. That now it's moving it to the top. And then the burnt gases get pushed out. Okay, it's really hard to understand that. Sometimes it's better to see it in diagrams. A lot of good working diagrams. I'll see if I can put one on my classroom, like illustrations like that show how that all works together. This is not a good way to show it, but basically what you have is you have a system here where you have very few moving parts. You don't have the camshaft. You don't have the valves. You also don't have a good way to lubricate that, right? We didn't mention oil. In this engine, we had oil in the bottom here. We can't really do that because we've got fuel coming in there. So that's why in a two-cycle engine, you mix some fuel with the gas. And so that oil film that's mixed in with the gas is in here around these moving parts, and it's enough to lubricate those parts. So it's an oil and fuel mixture. And so that's one of the other things. It's a really light engine. So if you have a handheld device like a chainsaw, weed whacker, something like that, now you've got something that's pretty lightweight to manipulate, to use. That's a big advantage. Another advantage too is you can move them in different directions. Okay? With an engine like this, if the oil is supposed to be in the bottom to lubricate, now we turn it sideways because we're cutting a tree down or something like that, that's not going to lubricate very well. But with this engine, the oil is mixed in with the gas, so it's always around the different parts of the engine, and no matter which way we turn it, it's going to get good lubrication. Bad thing about these engines is that lubrication isn't as good as this type of engine. So you're going to get, they don't have the lifespan, and they're going to wear out quicker. And also the exhaust, the emissions that come out of these engines is much dirtier. You're burning that oil. You're getting a little bit of gas because as that gas is getting pulled into the combustion chamber, the exhaust is coming out at the same time, so you do get some of that out through there as well. So the emissions are not as clean, so you have a more polluting, I guess, engine. But these two cycles have become more efficient over the years. They can make them run with much less oil than they used to, so it's not burning as much oil. And of course, you've got to mix it. Either you have to mix the oil with the gas in a certain ratio, whether it's 24-to-1 or 50-to-1. A lot of engines now, you don't have to do that, though. You basically have a separate feed pump. You put the oil in one tank and the gas in another, and as they're pulled in, it's mixed by a computer automatically, depending on what the engine needs for lubrication. So they've been able to fine-tune that a little bit better. But really lightweight engines, low moving parts. Every stroke down is a power stroke, so you get a lot of horsepower, a lot of power out of these, a lot of speed compared to a four-stroke. Every time you add moving parts in a system, like an engine like this, where you've got all these extra moving parts, it takes energy away from it, right, through friction and inertia, things like that. So this engine very efficient in a lot of ways and have a lot of advantages, but they also have some disadvantages as well. So hopefully you guys learned something about engines here. Two strokes, like I said, are a little bit hard to understand. I'm going to try to find a good illustration for you to look at to see how that works better. 4 cycles, a little bit easier to understand the 4 different cycles of the piston. And like I said, I'm gonna do another video that shows a car engine as well. I'm probably gonna do that right away. So hopefully you enjoyed it. Check it out, and you might learn something.